Okay, so today we are going to continue on with Lesson 5, ordering integers and other rational numbers. Today's problems include some word problems where you're going to have to actually read into the problem to determine if it is a positive or negative integer or rational number that you are looking at. So let's start with example 1. Example 1 says Sam has $10 in the bank. He owes his friend Hank $2.25. He owes his sister $1.75. Consider the three rational numbers related to this story of Sam's money. Write and order them from least to greatest. So that's important, least to greatest. Now, whenever I'm working with problems where I'm ordering them, I always start by figuring out how many numbers there are, and in this case it tells us there are 3. So what I do is I put 3 lines down on my paper that those numbers are going to eventually end up on. The next thing I do is I look back into the problem to see if it's least to greatest or greatest to least. In this problem, it's least to greatest, so underneath, I'm going to put L and then an arrow to G, just so I recall when I go to put them in order that it is, in fact, least to greatest. So looking back into the problem, the first number I see is $10, and it says that Sam has $10 in the bank. If you have money in the bank, that's looked at as a good thing, and it would be a positive 10. I'm just going to write these numbers down so I know which numbers I am dealing with. The next thing I see is that he owes his friend Hank $2.25. If you owe someone, that means it's going to be taken out of the money that you have, so it would be a negative 2.25. And then lastly, he owes his sister $1.75. So once again, he's owing some money, so that's a negative $1.75. Now with these 3 numbers, there's actually a number I can place without even looking at the numbers really. One of them is positive, whereas the other 2 numbers are negative. A positive is always greater than a negative, so I can put the positive 10 in the greatest section. Now I'm going to leave off the positive sign. You can put it on there, but typically we see positive numbers written without them, so I'm going to write it without. Now in order to compare the other 2 numbers to see which one is less than the other, what I particularly do is I write them as positives to the side, and I compare them as positives first. Now remember from yesterday, when you're comparing 2 numbers that include decimal or fraction, the very first thing you want to do in comparing them is look at their whole numbers. In this case, we have a 2 and a 1. The whole numbers are different, so we don't even have to worry about what comes after them. We can just compare them by their whole numbers. If their whole numbers were the same, we would have to look after the decimal, which we'll see in a problem coming up. But now just looking at these, 2 is greater than 1 when they are positive, but since we're looking at those numbers opposites, remember a positive and negative of the same are opposites of one another. So since we're looking at the opposites, the symbol is also going to be its opposite. So instead of greater than, it's going to be less than. So negative 2.25 is less than negative 1.75. So when I go to put them in order, negative 2.25 would be first, and then negative 1.75. There are, of course, many other ways that you can determine the order of those 2 numbers. You can use a number line like we did the other day, or you can even think of it, I've heard students say, how far are they from 0, which is another great way of doing it. I personally just use the starting with the positive and then reversing the order myself, but if that's a method that's not easy for you to do, or if you like one of the other methods better, please feel free to do that. Okay, let's look at the next example. Example 2 says Jason is entering college and has opened a checking account, which he will use for college expenses. His parents gave him $200 to deposit into the account. Jason wrote a check for $85 to pay for his calculus book and a check for $25.34 to pay for miscellaneous school supplies. Write the three rational numbers related to the balance in Jason's checking account in order from greatest to least. So we're reversing that order this time. Again, there are three numbers, so I'm going to put 3 lines. This time it's greatest to least, so I put my G to L. And now I'm going to read back to determine if they are positive or negatives. So a deposit, recall, is when you put money in, so it is a positive. It adds money to your account. So this would be a positive 200. I also want to say that we take off the dollar sign when we're looking at the integers or rational numbers that match with numbers. We take off any of the units. So it's just a plus 200 or a positive 200. So the next one is Jason wrote a check for $85. When you write a check, that money comes out of your account. So that means that that would be a negative $85. Or I'd be taking out $85 from the account. In that sense, he's also writing a check for $25.34, so that would be a negative $25.34. So once again, in comparing these three numbers, I can see one is positive and the other two are negative. That means I can automatically place that one that's different, the positive. It is the greatest number because positives are always greater than negatives. So the positive 200 would actually go on the first line because remember we're going greatest to least this time. In comparing the two negatives, I'm going to do the same method I did before where I write them as positives to the side. I'm going to look at the whole number piece of the numbers. 85 is just a whole number. So 85 and 25 are obviously different. As positives, 85 is greater than 25. But again, we're dealing with the opposites, the negatives of those numbers, which means it's going to be the opposite way. So it would be negative 85 is less than negative 25.34. So in going greatest to least, that means the negative 25.34 would go next, and then the negative 85 would be the least number. Again, if you have another method that you prefer, please feel free to use it. Okay, the next example is a little trickier. In this example, it says Shane found cards with different numbers on them. He wanted to put them in order from least to greatest, but was having difficulty since they included decimals and fractions. At first, he thought he should convert the fractions into decimals, but then his sister told him he should convert the decimals into fractions. Using the numbers on the cards below, try both ways and determine which way you think is easier. So again, we're given two different methods here. You can choose which one you like best in the long run. I'll show you which one I think is easier as we go through. So we're going to start by splitting our paper down the middle. And then we are going to write the numbers from the list vertically. On each side. So I want them so that they're on both sides because we're going to do two different things with these numbers. Oops. Okay, and then the next thing, I'm going to make my 4 lines on each side for the 4 numbers that we are working with. And if I read back into the problem, I see I'm ordering least to greatest, so I'm going to do my L to G, just so I don't forget that I'm going least to greatest in the long run. All right, so we're going to start by converting each one of these into fractions. So if you see, we already have 2 that are in fraction form, so we need to turn our decimals into fractions. If I'm to look at the negative 2.6, if I read this as a decimal, this is negative 2 with a 6 in the tenths place, so it's negative 2 6/10. If I think in my mind in fraction form, all that is negative 2 6/10, or 6 over 10. I can do the same thing for the negative 2.8. Read it as the decimal negative 2 8/10, which means negative 2 8 over 10. So now I have 4 fractions to look at. I should mention first, though, I should have looked at the whole numbers first to compare. And since they are all the same, the negative 2, negative 2, negative 2, that's why I have to actually look at the fractional part. So when comparing fractions, in order to compare them, you really need to have a common denominator. So if I'm looking at these denominators, I have 10, 3, 10, and 5. I have to come up with a common denominator for them. A number that 10, 3, 10, and 5 can all go into is 30. So I'm going to have to take each one of these fractions and turn them into a fraction with a denominator of 30. So I'm just simply carrying over the whole numbers and putting a denominator of 30 for each one. So starting with the first one, 10 times 3 is 30, 6 times 3 is 18. With the second one, 3 times 10 is 30, so 1 times 10 is 10. For the next one, 10 times 3 is 30, 8 times 3 is 24. And the last one, 5 times 6 is 30, 2 times 6 is 12. Once we have everything the same in all of these numbers except for their numerators, we're going to use the numerators to help us compare them. So we're really going to be looking at each one of these boxed in numbers. Something to remember is that they are all negative numbers, so it's going to be the opposite order as though they were positive. So if I'm going least to greatest here, I'm actually going to look for the numerator that is the largest, and that would be the least. So out of these four numerators, the largest one is the 24. I'm going to go all the way back from where that started at, which was the negative 2.8, and put that down on the line. As long as you show what it's equal to somewhere on your paper, it wouldn't really matter, but just be careful in the play pause it because it will go back to the original number. The next one is 18, and that goes all the way back to the negative 2.6, so that would come next. Then 12, so that would be the negative 2 and 2/5. And finally, the 10, negative 2 and 1/3. So if we were to convert them all to fractions, we have to first convert them to the fractions and then find a common denominator and compare their numerators. The other way we can do it is to turn all of the numbers into decimals. Now once again, two of them are decimals, so we just need to turn the two fractions into decimals. I'm actually going to start with the bottom one. In this one, the denominator is a 5, and if you recall, we can turn any fraction that has a denominator that goes into a decimal place value into a decimal pretty easily. So the first decimal place value is tenths. 5 can go into tenths. So 5 times 2 is 10, and 2 times 2 is 4. So 2 and 4 tenths, or negative 2 and 4 tenths I should say, is the same thing as negative 2 and 4 in the tenths place. Now the other fraction is a little different. The denominator here is 3. 3 can't equally go into 10, 100, 1,000, 10,000, or so on. So when we have a fraction like this, and this actually does work for any fraction, I could have done this with the 2/5 as well, I just think about what this fraction line means. And remember, it means divided by. So this is actually 1 divided by 3. If I put 1 divided by 3 in my calculator, it's going to give me a repeating decimal. It's 0.33333333 on and on forever and ever and ever. So the question becomes, where do I stop? What you need to do is look at the other decimals you're comparing it to. If you look at them, they all go to the tenths place. So this one will be kind of nice. You want to go take it out to the longest decimal's length, and you want to round it to that place. So in this case, the longest one goes to the tenths place, so I'm going to round it to the tenths place. Now this works nicely because when I do round this to the tenths place, it becomes 0.3. None of the other decimals have a 0.3, so that's why it works nicely. If, say, for example, it rounded up and went to a 0.4, we already have a 0.4, so we would actually have to round it to the hundredths and then attach zeros to all of the other decimals and compare them there. But this one does work out nicely where it doesn't match up with any of the other decimals, so we can use the 3. So in the same manner that we did the other one, we're now going to look at what comes after the decimal. We are going to, again, put them in order from least to greatest. We have to remember, again, they're all negatives. So we want to look for the largest one to go first. It's the opposite because they're negative. So the largest is so it would be negative 2.8. Then comes negative 2.6. Then comes that 4, which we're going to trace all the way back to the negative 2 2/5. And then finally, that 3. So negative 2 1/3 would come last. Notice your two lists are the same. So it's just about which process you choose to go with. Me personally, I would go with the decimal version because there's a lot less room for error. And I think it's a little bit easier. For your decimals, you just have to divide, and your calculator will tell you what your decimal equivalent is. Whereas if you're looking at fractions, which I know earlier a lot of kids said, oh, I would go with that method, but you have to think about your denominators. You could have fractions with a denominator of 6, 7, and 8. To find the common denominator there, you would end up doing 6 times 7 times 8 and getting a very large number and having to deal with some really big numbers in comparison there. So personally, I would lean you guys towards the decimals, but if you're more comfortable with the fractions, again, please feel free to use it. So right now what you're going to do is you are going to go into your Playposit and work on the exercises. I do want to remind you, if it's a negative number, it needs a negative sign. Also, with the ordering, make sure you put it back to where it was in the original spot. Otherwise, it could mark you as wrong even if you have a correct decimal equivalent, just because that's the way that it was put into the computer. So go ahead and good luck.